Oh, well, hello, folks. How are we today? We're continuing through this idea of logs and all kinds of fun stuff here. And that brings us to the next part. So if you remember, the first part of this chapter, we did simplifying exponential expressions, just reviewed that. And then we just reviewed how to simplify a log without a calculator. And along the way, we had a few different rules that helped us out here. Our first rule that we had was our definition of logs. Let's see here. Whoop. All righty. And that said that the log of base b of any number x equals y, if we wanted to, we could go through and change that to its exponential form. And we said, well, the base of the log is going to be the same thing as the base of the exponential form, but the x and the y, they would trade spots. Okay, so we had that two things that helped us out a little bit, and we went through and we talked about that. We looked at some of these things. Some other things that we looked at along the way is we looked at anytime you're taking the log of 1. We said that was equal to 0. Okay. We also said that if your base of your log equals the number, well, then that equals 1. So these were kind of our three little rules and things that we followed here. And then we also talked about two other things. We talked about the common log and the natural log. And again, just a reminder that E is that Euler number. It's that base of the natural log. And again, that is right here. Isn't quite right. I should switch that. That should be log base E. And so if there is no base, we assume the base is 10. If there is an ln, that's that base of E, and E is that Euler number, that 2.71828182834, yada, 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 go on forever. And we treat that just like an I. We treat that like pi. It's just some random constant. Well, now we're going to go ahead and get ourselves to the point of looking at some properties of logs. So for instance, if I'm multiplying two numbers inside a log, I can separate that with addition. I'm not really sure why this ended up over here. That's kind of funny. That should have been over there, whatever. Anyways, so if I want to break up two logs and there's multiplication going on between them, then we can break it up with addition. Likewise, if I have two logs that are being divided by, and remember a fraction bar just means divided by, I can break them up with subtraction. We talked briefly about this one the other day, that if I have an exponent in a log, I can bring it out in front. And it becomes an exponent, or it becomes multiplying. So an exponent can go out in front and become multiplying. Likewise, if I want to move this exponent back, I could do that and make it the exponent. So these go both ways. So what I mean by that is, if I see one thing, depending on what I want to do, whether I want to make it bigger or smaller, I can go both ways with all these things. I can go back and forth between all these different properties. So they can go back and forth. And then this idea right here, this kind of alludes to this idea that logs and exponents are inverses of each other. And we talked about this a while ago, back at the beginning of the school year, when we talked about inverse functions. We briefly talked about logs. And since they're inverses, they undo each other. So that way the log, if you have b as the base of an exponential function, and the log of that same base is in the exponent, they would undo each other, and you're left with just whatever that exponent is. And again, like we said before, you can't take the log of 0, can't take the log of a negative number. Those are big no-nos. Can't do that. Also, you can't have a base that is a negative number or 0 as well. So all these different things come into play. Last thing, there is something called the change of base, and we'll look at this in a little bit. It's not really needed, because you can solve things fairly quickly just by doing them doing something called logging both sides, which we'll talk about over the next couple of days. It's not really needed, but that does exist as well. So anyways, we have all these rules of logs, and we're going to use them to kind of help us out with some things. So first thing we're going to do is we're going to do something called expanding a log. And that means we're going to take one log and we're going to expand it. Okay. And in order to do that, we're going to be using those same three rules that we had before. So those same three rules, they're going to still come into play on us here. So that's kind of good. I didn't want to go away, did it? There we go. All right, now we can write over the top of that. All right, so our three rules of logs. So first up, just as a little reminder, if I'm taking a log, any log, and I am multiplying two numbers inside, I can separate it with addition. So log base b of x plus log base b of y. So we're going to use these rules to help do what we call expanding things. We're going to break them apart and make them, instead of having one log, we're going to make them have multiple logs. Likewise, if I have a log and I'm dividing like we just said, we can break it apart with subtraction. So that would be log base, whatever the base is, doesn't matter, x minus log base y. One of the biggest things to remember is if you have multiple numbers in the numerator, treat those as multiplication, and multiple things in the denominator, treat those as addition. I'm sorry, subtraction, division. All right, and if I have some log where I have an exponent, if I'm going to expand a log, make it bigger, that means that exponent is going to come in front. So we're going to use our log rules to try to expand logs. So I'm going to try the first one here. I don't know why we're going 1 to 13. Something happened with the auto type there, but whatever. All right, friends. So let's see how this looks. So we're going to expand these so that everything gets to have its own log. So when I go to expand them, anytime I'm multiplying, I'm going to add. So multiplying means to add. Another way to think of it is anything in the numerator is adding. Anytime we are dealing with division, division means subtract, or anything in the denominator, you would subtract. So 25 is in the numerator. That is a positive log. There we go. Now notice I have two things in the denominator. I have a 6 and I have an e. So if we have two things in the denominator, each of those things I can bring them out and expand them with subtraction, because division means to subtract. And I can take this one step further if I want to expand this even more, because 25 is the same thing as 5 squared minus natural log of 6 minus natural log of e. And I got two more things that I could possibly do here. Now, one of them is if we have an exponent, the exponent comes out in front with multiplication. So that's going to be one thing that I'm going to do. And the other thing that I could do on this particular problem is this. If you remember that natural log of e is the same thing as log base e of e, you would notice that the base and the number are the exact same thing. So that means that natural log of e would be equal to 1. So we can make that little substitution there. So if we want to expand this even further, the 2 here would go out in front and become multiplication. So 2 times natural log of 5 minus natural log of 6 minus 1. And now it is completely expanded. I want you guys to go and pause the video and see if you guys can expand these next two. All right, friends, let's see how you did here. So we have the natural log of the square root of x squared y cubed. So the first thing I would do is I would go ahead and I'd make my square root kind of clean it up a little bit. So that'd be the square root of x squared all over the square root of y cubed. And the square root of x squared, well, that would be x. And the square root of y cubed, I would turn that into a fraction. So that would be 3 halves. So anything in the numerator is a positive log. So natural log of x. Anything in the the denominator would be a negative log. So minus natural log of 3 halves. All right, friends, we just about are done with this one. We just got to take care of that 3 halves now. Again, this is called expanding logs. We don't really do much with expanding logs in algebra. They don't really help us out a whole heck of a lot. But I'll be honest, in calculus, you will use them quite a bit when you're doing something called the derivative of a log. So it's kind of important to know. It's a good thing to know. It'll make your life easier next year. All right. And our last one, let's see how you guys did on this one. So it says log base b. So this could have been any log. Didn't really matter. So log base b of x squared root w. And then we have y squared and z to the third. So every log in the numerator is like multiplication. So we're going to separate it with addition. So log b x squared plus, now that root w, I'm going to change it to an exponent. So remember that the square root is the same thing as the exponent to the 1/2. So there's our 1/2. And then I got two things in the denominator. So we're going to be able to go ahead and separate those with subtraction. Because anytime you were dividing logs, we can break them apart with subtraction. Minus log base b of z cubed. And then we got a whole bunch of exponents here. So every one of these exponents, they're going to go in front of the log. Again, this is called expanding. So 2 log base b of x plus 1/2 log base b of w minus 2 log base b of y minus 3 log base b of z. So these, friends, these are called expanding logs. So we took the logs and we made them bigger. All right, so the next thing we have to do is condensing logs. So when we're condensing logs, again, we will still go ahead and we're still going to need all our rules to come into play. So let's make sure we bring those rules back in here. But this time I'm going to write them the opposite way. In other words, if I have a log that is being added, or 2 logs that are added, I can put them together with multiplication. So I'm going to keep my rules up here so I can see them. Log base b x times y. And if I have 2 logs that are being subtracted, I can put them together with division. So when we're condensing logs, and this is what we would do to solve a log equation like we will next class. We solve a log next class in algebra. This is where you would actually want to go ahead and condense them, get them to a single log. So the expanding logs we just did, we won't use that until calculus, but now when we're going the opposite way, and we're condensing, and this is more of an algebra, how we would solve with algebra. So let's see how this whole thing works. All right, so to condense, the first thing we want to do, well, I have this 1/3 here, so that's not real friendly. So I'm going to go ahead and distribute that real quick. We're just going to do some straight algebra. All right, so I end up with 1/3 log base 3 of 7x and 2/3 log base 3 of y minus 5 log base 3 of z. So when we are going through and condensing, we're going to go the exact opposite order. So I'm going to take all these numbers in front and they will become the exponents. So log base 3, 7x, and even though we have a 1/3, that's technically a cube root. We can leave them as fractions. We don't have to go and turn them into radicals. We can leave that as an exponent. Plus log base y of 2/3 minus log base, I should have been a 3 there, sorry about that. Log base 3 of z to the 5th. All right, so now we got everything back in terms of exponents. And now we can write as a single log. And remember that every positive log, and notice this only works when the bases are all the same. They all have a base of 3, so this works. If they don't have the same base, I can't combine them. So every positive log is like multiplying, it's going to go in the numerator. Every negative log is like division, it will go in the denominator. So 7x to the 1/3, that's a positive log. Positive log base 3 of y to the 2/3, so that's another positive log. So that's also going to go in the numerator. And minus log base 3, that's another base 3. So, but it's a negative log, so that is going to go in the denominator. And friends, that's all we're doing. All right, why don't you guys go and pause the video and see what you guys can come up with on these next two. All right, let's see how we did here, friends. Here we go. Again, I see that -2 there. So I'm going to go ahead and just start off and distribute those logs in here. So that's -2 natural log of x plus 2. And I'm going to go ahead. So once I distribute it into there, I'm also going to go ahead and distribute it into here. So that's a -2 natural log of x minus 2. Just like that. And now all those numbers in front, they become exponents. So minus natural log of x minus or x plus 2 squared minus natural log of x minus 2 squared. So natural log means these are all logs of base e. They have the same base, so I can put them together. The positive logs go in the numerator. The negative logs go in the denominator. So there's a positive log. Here's a negative log. And a negative log. That is condensed. All right, on this other one here, I'm going to go a little higher here, give myself a little more room. I see the 1/3, so I'm going to go ahead and distribute that in. So I have 1/3 natural log of y plus 2/3 natural log of y plus 4. And minus natural log of y minus 1. And again, every number in front of a natural log becomes an exponent when we're condensing. So this is y to the 1/3 plus natural log of y plus 4 to the 2/3 minus natural log of y minus 1. All righty. And now every positive log goes in the numerator. It's multiplication. Every negative log goes in the denominator because it is subtraction. So that's a positive log. Looks like I have two positive logs here. So they're both going to make it into the, whoopsies. They're both going to make it into the numerator. Let's make that sound like it's a privilege. Oh, you get to go to the numerator. All righty. Well, friends, I know. You do enough videos, you start talking to yourself. What can I say? Over y minus 1. All righty. That's condensing. Okay, and the last thing you're going to be asked to do today is, again, just go through and evaluate some logs. Okay. And now that we have our new log rule, and sometimes you might get a fun log, a different log, something like log base 7 to the 49. If that's the case, you don't have to go through and set it equal to a variable like we did before. If you want to, if it's possible, you can go through and use our new properties of logs to figure out where everything goes. And friends, if you notice, if I can make the base of the number be equal to the base of a log, I can actually use a little bit of a shortcut here, and I can solve this quicker. So that would become 2 times natural log of base 7. So as you're going through, if you get a chance to actually be able to use one of our shortcuts using our properties of logs, feel free to go for it. If not, you can always set it equal to a variable and solve. So go ahead and pause the video, take a second and solve these, and then we will go through and solve all of them together. All right, friends, let's see how you did. So log base 9 of 243. All right, well, 243 it cannot be written in terms of 9. So I'm going to go ahead and set that equal to a variable. So I have 9. So the base will always be the base, and the variable and the number, they change sides. So 9 and 243, they are numbers that can all be bases of 2. So I can go ahead and change that up here. So 9 is 3 squared. 243 is 3 to the 5th. So that means that this is 3 to the 2x equals 3 to the 5th. So 2x equals 5. And friends, that means x is 5/2. So that's equal to 5/2. And another thing you could do is, if you wanted to, you could use your change of base formula to plug it into a calculator. And what I mean by that is this. If you wanted to just plug in your calculator, you could do your change of base and say, okay, well, the log base 9 of 243 is the same thing as log 243 divided by log 9. And if I plug that into my calculator will tell me that it's 5/2. So if you wanted to, you could do the change of base formula. I'm not using the change of base formula just because, again, it's not something that really needs to happen. I mean, if you want to, go for it. No big deal. All right, this next one here, I cannot write 128 in terms of 4. No harm, no foul. That's okay. I can go ahead and either do my change of base formula, or I can set it equal to a variable. So I'll just go ahead and set it equal to a variable here. There we go. All right, so we have 4 to the x equals 128. And these are all powers of 2. So that's 2 squared, or all have it be written as a base of 2. 128, that would be 2 to the 7th. So that means that is 2 to the x equals 2 to the 7. They have the same base, so I can get rid of the bases and set the exponents equal to each other. So x is 7/2. So I would have solved it that way. Again, if you want to use a change of base, you can. You can use the common log if you want to, or if you wanted to, you could have gone and actually made it in terms of like natural log. You could have done natural log of 128. This is the change of base formula divided by the natural log of 4. And if you plug that into your calculator, if you have a calculator available to you, it would have also told you the same answer. So again, could have done the change of base formula on that one. All right, our last one. Log base 5 of 125. Well, on this one, I kind of like this one because I know something about log base 125. That's the same thing as 5 to the 3rd. So that means that this equals 3 times log base 5 of 5. And you can see how our properties of logs can make this a lot quicker than having to use a variable. So 3 times 1, which is 3. And again, if you wanted to, you could also solve that one using your change of base formula. If you wanted to. I wouldn't have, but if you want to, again, use the common log or the natural log. Doesn't matter which one you use. I'll use the common log again this time. So that's a common log, remember, is the log of base 10. So the change of base says log of 125 divided by log of 5. Plug that into your calculator and it will tell you the answer is 3 as well. So that's if you have a calculator available. If you don't have a calculator available, no harm, no foul. You just go right on ahead and use our properties of logs or our definition of log and we can solve it. All righty, friends, that takes care of this one. Hope you're having a wonderful, wonderful rest of the day. And I will see you guys tomorrow in class and we'll talk more about this. All right, take care. Bye-bye.